possible, solve the system. I'm going to use a matrix method to solve this system. So what I'm going to use is an augmented matrix and row operations. So the first thing that I'll do is I'll rewrite this in an augmented form. So I could write the matrix 2, -3, -1, 13, -1, 2, -5, 6, 5, -1, -1, 49. All right, now my first goal is to make this first element in the diagonal a 1. Now I could do that through division. That's going to give me some nasty fractions. So instead what I'm going to do is I'm going to see, well, I have this -1. I can change the rows and multiply by -1. So instead what I'll do is I'll switch these rows, giving me -1, 2, -5, 6, 2, -3, -1, 13, and 5, -1, -1, 49. Now what I can do is multiply row 1 by -1. So let's take -1 times row 1 and use it to replace row 1. So that would give me 1, -2, 5, -6, 2, -3, -1, 13, 5, -1, -1, 49. Alright, so now I have the 1 in the upper left element. So now I'm going to focus on the elements below it. I need to make those zeros. So the row operation I can use is take row 2 and add to it -2 times row 1. Similarly, I can take row 3 and add to it -5 times row 1. Alright, row 1 stays the same. 1, -2, 5, -6. Row 2 plus -2 times row 1. 2 plus -2 times 1 is 0. -3 plus -2 times -2 is -3 plus 4, which is 1. -1 plus -2 times 5 is -1 plus -10, which is -11. And 13 plus -2 times -6 is 13 plus 12 is 25. Now a lot of students make errors with the arithmetic here. So if you have a calculator, what you can do, so that row operation was row 2 plus -2 times row 1. I can input row 2 as an array. And so if you hit second and the left parenthesis, you can now type in row 2, so that's 2, comma, -3, comma, -1, comma, 13. Close off that array. Now I'm going to add to it -2 times row 1. So row 1 I'll enter as an array, second left parenthesis, so make sure you're bringing up those array symbols. You can't use parentheses, it just doesn't work. So -2 times row 1 is 1, comma, -2, comma, 5, comma, -6. Alright, close off the array and hit enter. And those are the same 4 elements that we got. 0, 1, -11, and 25. So now I'm going to do the same thing, but with row 3. What did I had? Row 3 plus -5, row 1. Alright, so second parenthesis, row 3 is 5, comma, -1, comma, -1, comma, 49. Close it off. Add to that -5 times, now row 1 is again, open the array, 1, comma, -2, comma, 5, comma, -6. Close the array, hit enter, and I get 0, 9, -26, 79. All right, my next row operation, well, the next goal would be I need to make this a 1. Well, it's already a 1, so let's now focus instead on the 9. So to make that 9 a 0, I'll take row 3 and add to it negative 9 times row 2. And again, I'm going to use the calculator here to help me with the arithmetic. All right, so let's see. Oh, my last answer was row 2. Well, I'm sorry, it was row 3. So I'm going to take my last answer, and I need to add to that negative 9 times row 2, bring up the array, 0, comma, 1, comma, negative 11, comma, 25, close it off, enter, and I get 0, 0, 73, negative 146. All right, finally, let me multiply row 3 by 1/73. And so that would get me to row echelon form. So I'd have 1, negative 2, 5, negative 6, 0, 1, negative 11, 25, 0, 0, 1, negative 2. Now that I'm in row echelon form, I can figure out the actual values for x, y, and z by using back substitution. So now using back substitution, I know that z is equal to negative 2. Then y minus 11 by negative 2, y minus 11z is equal to 25. And so then y plus 22 is 25, which implies that y equals 23. And then using the first line, I have x minus 2, I'm sorry, that's not 23, just plain old 3. X minus 2 times 3 plus 5 times negative 2 is negative 6. So x minus 6 minus 10 is negative 6. X minus 16 is negative 6. X equals 10. So the solution of the system is the ordered triple 10, 3, negative 2.